what is meant by unidentate, didentate and ambidentate ligands? Oh my God. Give 2 examples of each. Denticity means the number of lone pairs which is donated by a given ligand to a single metal atom. Mark my words, if one ligand donates one lone pair to one metal atom, that would be a unidentate ligand. Okay, that's nice. For example, I'll give you the example like H2O. H2O is an example of unidentate ligand. Why? Because it donates only one lone pair. It does not donate more than that, and that too only to a single metal atom. If you have OH minus, OH minus also is a very beautiful example of a unidentate ligand. Why? Because although it has 3 lone pairs, but it can get attached. Yeah, it can donate only one lone pair to one metal atom. Please note, OH minus might be able to donate one more lone pair to somebody else. These donated lone pairs are through coordinate bonds. Coordinate bonds are sigma bonds, and if you have one metal atom attached to OH minus, there is only one sigma bond possible. You cannot have two coordinate bonds like this with the same metal atom. Even if there is M2 and the other lone pair is being donated to M2, still OH minus would be a unidentate ligand only. Why? What is the definition? The number of lone pairs donated by a given ligand to a single metal atom. People eat away to a single metal atom and then keep getting confused. I'm removing that point of confusion by giving you the exact definition. Single metal atom. Don't miss out on that. So this interaction would be counted in denticity and absolutely nothing else. So there you are. Got it? Absolutely got it. Bidentate is done. And ambidentate ligands. Oh my God, what are ambidentate ligands? Amphibians, both land and water, animals which can live both ways. Ambidentate, if a given ligand can donate a lone pair in more than one ways. What is more than one ways? Usually through 2 different atoms or more different atoms, and that ligand is called an ambidentate ligand. If a given ligand can donate a lone pair in more than one ways, then that ligand is said to be an ambidentate ligand. That is the definition. Give me an example. Well, I will give you example. Didentate, I'll write down examples, but let's finish ambidentate first. If you have cyanide ion, for example. Now, cyanide can get attached through carbon or through nitrogen. This is called cyanide. This is isocyanide. Old name, but nonetheless a name. So cyanide in that sense becomes an ambidentate ligand. Yes, very much. Anything else? Of course. A very famous case, you have NO2 minus. Now NO2 minus could actually donate the lone pair through oxygen. Yes. It could also donate the lone pair not through oxygen but through nitrogen. Yes. So NO2 minus also becomes ambidentate ligand. Why? It can be attached to a metal atom either through oxygen or through nitrogen. In more than one ways the lone pair can be donated. It is ambidentate. Yes, very much it is ambidentate. None. What about didentate? Didentate, if 2 lone pairs can be donated by a single ligand to a one metal atom. I'm just covering the middle point, didentate ions, ligands. What is a didentate ligand? A ligand which can, yes, go ahead. The ligand which can donate exactly 2 lone pairs to one single metal atom would be termed as a didentate ligand. For example, ethylene diamine, very classic case, NH2. CH2, CH2, NH2. Beautiful molecule. Is it a didentate ligand? Very much. Why? Look at the way it donates lone pairs. 1 and 2. And both are donated to the same metal atom. Is this a didentate ligand? Indeed. This is a didentate ligand, ethylene diamine as people lovingly call it. Is there another example? Of course there could be. Let us say another metal atom we have, and let's take a very famous and a very popular one, oxalate ion. The very lovely oxalate ion. They can donate a lone pair each. Oh my God, there are two lone pairs donated. Yes, by one oxalate ion. Indeed. So what is that? This is a didentate ligand. Indeed, they are two classic examples and very popular examples of didentate ligands.